In our timing analysis for the IEC 61499, we gather WCET information for all input events of a function block. The WCET of a basic function block is determined by analysis of its ECC. For each input event, we find all possible ECC runs and gather information on WCET values of executed algorithms and produced output events. In our prototype implementation, the WCET values of algorithms are defined by hand as parts of the algorithm comments. Once we have defined WCET values for all algorithms of a BFB, we can execute timing analysis on that function block. This is done by accessing analysis menu added by our plugin. When starting our analysis, we can choose data normalization algorithm to use for the analysis. Based on the chosen normalization algorithm, during analysis we remove redundant data or introduce overestimations which help us reduce the size of the WCET dataset. We can also choose how analysis will behave when executed on a composite function block. In case there is no data for an enclosed function block, we can either stop the analysis or calculate the WCET data for the function block also. We can also force recalculation of WCET for each enclosed function block. When the analysis is finished, we are presented with the results. Here we can see different WCET data for each input event of a function block. The data includes WCET values and number of output events produced. Results of the analysis are also stored. In this prototype implementation, we store the results as serialized Java objects in the function block comments. Results can also always be accessed using the analysis menu. As the functionality of a service interface function block is not defined by the standard, we have not implemented a method for analyzing their WCET. However, we can define WCET data for them manually using the WCET editor. As service interface function blocks can start their execution without any input event triggering them, we can define WCET data for periodical execution also. WCET of a composite function block is analyzed using their internal function block network. We only take into account event connections between function blocks while disregarding any exchange of data. If we do not choose forced hierarchical analysis, results of previous analysis of internal function blocks are reused. Results of a composite function block analysis are presented in the same way as for the basic function blocks. In case a composite function block contains a service interface function block, periodical execution WCET is also calculated for the composite. Analysis can also be executed for applications. In this case, we only gather periodical execution data as applications do not have event inputs.